All right. Good afternoon. It's a pleasure to welcome you all again to another session where we connect under the banner of Code Without Barriers. This initiative is not just a program, it's a mission to reshape the tech industry by promoting diversity, inclusion, and opportunity for women in tech. Despite progress, women remain underrepresented in the fields like artificial intelligence, cloud, and security. Programs like Code Without Barriers aim to accelerate change. Since its launch in 2021, the program has achieved skilling over 38,000 women developers trained globally in artificial intelligence, cloud, and security. Partnerships, onboarding partners to further dive into Code Without Barriers mission in their organization. Hackathons, over 4,500 participants worked over 63 impactful projects. Mentorships, 120 mentors guiding 1,000 mentees to build confidence and leadership. Communities, hosting virtual and in person meetups for female developers to interact and learn from each other. In India, uh, the program is transforming lives. During his recent tour, Satya Nadella announced the goal of upskilling 75,000 women developers in a year, with over 35,000 already skilled. Today, let's celebrate this achievement and recommit to driving this mission forward. To help us dive into today's session on the fundamentals of machine learning, we are thrilled to welcome back two incredible speakers who led a fantastic session yesterday. Manisha Talreja, a data engineer at Microsoft, and Herleen Kaur, a senior consultant specializing in information and security and DevOps at Microsoft. Their combined knowledge and insights will provide a solid foundation in learning machine learning and its applications. Let's give them a warm welcome. Over to you, Manisha and Herleen.
Thanks, Kamya. So I'll take it over from here. I'll start sharing my screen. Okay. Okay. So let's get started. I'll start with a quick introduction. I'm Harleen Kaur, a senior consultant with Microsoft in the field of cybersecurity. So I have been with the organization for 5 years now, and I have an overall 1.5 decades of industry experience. So in my day-to-day job, you will see me working with customers on DevOps transformation, on engineering excellence, and of course on the information security topics. So I'm joined by my co-host Manisha, who is a data engineer at Microsoft and has a rich experience of 6 years in the IT industry, and she is with the organization for 6 months now. So we are both thrilled to be here today to talk about machine learning. So let's make this session very interactive and insightful. So during the session, if you have any questions, feel free to leverage the chat. Okay, so in the presentation today, I will be talking about mm, like why do we need machine learning? How did the need arise? Is it something new, something recent? What actually is machine learning? We will share some real world examples where you see machine learning in your daily life. And then we will introduce you to Azure Machine Learning and share some real world implementations of the same um, in the industry. So let's get started by talking about the evolution of how we utilize the data and why machine learning has become essential in our current landscape. So initially, if we talk about our approach to data, it's quite basic, right? We relied heavily on the static reports and the manual processes. So by the time you used to gather all the data and produce the report, the data has already become obsolete, and it required a lot of effort on the human side to produce and then interpret that data. Then, as we had the advancements in the technology, we moved towards having more interactive dashboards. So these dashboards allowed us to have real-time insights into the data and allowed us to play with the data in real time, segmenting the data. So this provided a significant improvement over the static reports by enabling us to have quicker insights and making allowing us to make more informed decisions. Today, we are in the era of predictive analytics, right? So what we do is with the advent of machine learning, we can now analyze the data to understand where this data is coming from and also to predict the future trends and the behaviors. So this shift, it's allowing us to see what has happened and also to anticipate what may happen in future, right? So I can quote an example here. Of if you think about the customer churn for a subscription based business, like number of customers who may cancel their subscriptions for say businesses like Amazon Prime, or if you talk about food delivery apps like Swiggy, yeah, they have their Swiggy One program, or Zomato has the Zomato Gold program. So if those companies have to think about their customer churn and predict the customer churn, if they relied solely on the static reports, the manual processes, uh, when somebody would cancel their subscription, these organizations would have known only by the end of the month, that when the report would be produced, that okay, these many people have canceled their subscription. So these organizations would then maybe reach out to those customers asking, okay, what is the reason for cancellation? They may offer them, say, some um, um, they may offer some some subsidized rates or low rates on renewing the subscription to gain that customer back, right? But this is more of a very reactive approach. Uh, Now, if we think about same example in terms of the interactive dashboards, um, think of Amazon and somebody who is using Amazon Prime, who is canceling that subscription. Amazon will know right um, at the time when the customer cancels their subscription. In real time, they will know that okay, this person has canceled their subscription, and then Amazon may segment the data in terms of what has been the usage pattern for this particular customer, what is their demographic, what location they are based in, what is their age group, right? So they can get those immediate insights. And if we look at these examples from the predictive analytics standpoint, the era that we are in right now, using machine learning, the companies, they can predict which customers are likely to cancel their subscriptions. Like if I am a very active user of Amazon Prime and suddenly I stop using the Prime services, I stop ordering on Amazon, what Amazon will do is will have personalized offers for me. They would do targeted marketing for me. Okay, maybe on when I'm watching YouTube, ads for Amazon will start coming up, or I will start getting notifications that the subscription for Amazon is coming at a lower rate, and also there are these offers specially for you. So those kind of targeted marketing and personalized offers these companies can provide, which will help them retain the customers. So we have moved from an era wherein we used to know about customers after they have done the action to a stage wherein we can predict the customer behavior and accordingly adjust our marketing, our offers based on the customer needs. So what it does is it helps us to increase our efficiency and accuracy. It helps us to scale, and it also provides us a competitive advantage, right? Because we are making more data driven decisions, um, and we are making them at a faster pace, right? So em- embracing ML, machine learning, it's not about just keeping up with the technological advancements. It's also about staying ahead in this data driven world, staying ahead and staying ahead of our competitors as well. Right? So that's where the need arose, and that is how we have been using ML. Now, with this context, let me introduce you to what machine learning is, right? So I'll give you a minute to digest the left side of this slide, wherein we have a cartoon, and it is talking more about where AI was in past and to where it is advancing in the future. So in the past, AI, it was more about having some machine learning in terms of um, analyzing some data just for the calculation purposes. And then the way we are growing from a technology standpoint, the machine learning algorithms can empower the AI in the future to even tell you that, okay, maybe your shoelaces are untied, you need to tie them up, and they can remind you for any important upcoming events, right? And if you see on the right side of the slide, it's about the um, trend of the search for the phrase machine learning. Okay, if we look at the trend of searching for machine learning phrase on the internet, from around 2004, there have been very less searches, but from around 2016-17 timeframe, we have seen a sudden increase in the number of searches, and this is growing at a very fast rate, right? And this is because of all the technological advancements that are happening. And our very own Bill Gates once said that if we invent a breakthrough in artificial intelligence in such a way that maybe machines can learn, it can be worth 10 Microsoft. And I think it is the time now because we are advancing in machine learning like anything. So, what is machine learning? So, machine learning is getting the computers, allowing them to program themselves. We have seen an era wherein we sit in front of computers, write code, any of the rule set changes, we will then have to change our script to ensure those conditions are taken care by the code. Now, with machine learning, what we are doing is we are letting the computers to program themselves. So if you think of programming as an automation, machine learning is more about automating that automation process. So writing software, most of the times, it is a very cumbersome job. We have developers today which are more inclined towards more of a low code, no code solution. So what we are doing is letting the data work instead of the people. So we are giving the machine learning algorithms an opportunity to learn from the data and helping the programming to scale. So how the machine learning is different from any traditional programming that we do, right? Like in traditional programming, what we used to do is we write a certain lines of code, okay, and then we would make sure that that code is able to handle all the scenarios I, as a person, can think about. I'll give that code then to the testers. They may think about few more scenarios, and they would tell us that please include these as well. Okay, your code does not work in these conditions. So I would then again include those scenarios, and that back and forth was too much in terms of if you have to make that code out in the market for people to use, it requires a lot of work between the humans to make it actually work and cover all the scenarios which may happen, right? So with machine learning, we are giving the computers the ability to predict and make the decisions without explicitly programming every scenario, every decision, right? So what we are doing is we are having algorithms that can learn from the given set of data. They can make predictions based on that data, and then they can take decisions in which particular environment, in which particular environment they have to react, in what way, what kind of output will be produced. And we will talk about the different real life examples of the same. So if you use the Microsoft Store, or if you use Netflix, right? So by comparing what I have purchased in the past or what I have viewed in the past, the machine learning algorithms are able to make suggestions for me, right? So if you open your Netflix, that it would say, because you watch so and so, so you may also like this and this series, this and this movie. So what is happening behind the scene? The machine learning is learning from your behavior. It is drawing a pattern, saying that okay, rather than giving me a complete list of things, and I may not be able to choose what do I watch. It is like, because I have a tendency to watch more thriller series, these are the recommended series that we have, right? So machine learning is what is being used by Netflix. So it is being used for the content recommendations, to analyze the viewer habits and preferences. Then it also generates the thumbnails based on the user preferences, which means that if I am and the end user of Netflix, I may see a different thumbnail for a movie than Manisha, because the whole idea of Netflix is that they have to generate a content for me, which will be attracting me to watch that particular movie, right? So that is more of a personalized thumbnail. So they may take up a clip from the movie or from the series and present me that. Now, another area where Netflix uses uh, ML, it's also in the streaming quality, right? My internet connection may be very good during the day, but during the night, maybe I will have a low bandwidth. But I want to continue watching Netflix, right? So what will Netflix do? It will adapt the video quality based on what is my network bandwidth, how is my internet connection in real time. So that will help reduce the buffering time, rather than those old days wherein you used to click on pause button, let the stream to buffer, and then again play uh, mm, to see and to continue watching the movies, right? Then also Netflix uses the predictive caching, so which means that if I have seen people in India watching this particular movie mostly, I would cache that movie so that it it's like um, preloaded on the local servers, and then the buffering time, the streaming quality is higher than for that particular content, right? And it also helps in like it also leverages ML for content creation, wherein we make certain informed decision about, okay, you see, Netflix says that, okay, these are like top 10 movies in your area, right? What is it doing behind the scene? It is analyzing all the data, what is being watched in India, what is being watched in the northern parts of India, etc., and then it provides you with that particular content. So these um, all these different applications of machine learning, they not only enhance uh, the operations of Netflix, it also enhances the user satisfaction. So I'm paying certain amount to Netflix. I'll continue paying that because you are giving me what I want to see, right? So that's how machine learning is helping. So, we keep on hearing terms like AI, machine learning, deep learning. So, I want help of my co-host Manisha to make us understand what all these different terms means.
Thank you, Harleen. Hi everyone, this is Manisha Talreja. We know we hear about all these things, but actually, how are these things associated to machine learning and how everything makes one proper model working? So it's not just machine learning. There are other things as well, such as deep learning, artificial intelligence, data science, data mining, everything. When we put together in a working project, then only we will see the results. I mean, then only we will see the proper working model or proper working software which is associated to AI, which is associated to ML. So when we talk about deep learning, it is a specialized subset of machine learning. It is already included in machine learning. So without deep learning, machine learning cannot be achieved. Without machine learning, AI cannot be achieved. So everything is interrelated to each other. So when we talk about deep learning, it uses neural networks to process the data and identify patterns. So it has been revolutionary in tasks such as, that require high dimensional data understanding, such as computer vision, natural language processing. So once you start with the basics, once it requires intensive data training. It requires using of high models to train the data, and then we can step ahead to the machine learning. And then after, as machine learning has already been covered by my co-host Harleen, then it comes artificial intelligence. Once you have achieved deep learning, once you have trained your model, and then it comes the higher or the bigger picture is artificial intelligence. It means that machines are mimicking humans. They perform tasks that typically require human intelligence, such as decision making, problem solving, and natural language understanding. Suppose we AI basically means what users see at the end result. I mean, when you use a software, when you use an application, example, chatbots, autonomous vehicles, and expert systems. So you just, even if you use chat gpt, or nowadays you have seen a new car, Mahindra BE6E, which is not which has some features of Tesla, such as automated parking. It does car, you just press a key and the car will automatically park, looking at certain conditions. So how that is the end result? You are just seeing that car, but how is it, how is that feature made available to that car? It's just because it has been trained in with a large number of data sets. It has been trained with deep learning, machine learning, and then the final result you get is AI and data science. So data science is also related to data. So these are the models or algorithms, machine learning, deep learning, where you give your data, but you cannot give random data, right? You need to use statistical methods, algorithms, and systems to extract meaningful insights from structured data and unstructured data. So when you see memes, Instagram posts, Twitter, posts on Twitter and all those things, you cannot directly give that data, right? First, you need to extract the data from somewhere, from unstructured data or the relational data from databases, and then you will train that data, you will clean that data, process the data so that you can show the data on reports, Power BI reports, Fabric, and then that data is used to train the model, because the model obviously requires a clean and a systematic data, right? And the examples like predicting customer churn, analyzing market trends, optimizing business operations are some examples of data science. So how it is related to ML? Data science provides the foundational data and pre-processing needed to train ML models very effectively. Fourth is statistics. It's mainly a branch of mathematics. It is used for collecting, analyzing, interpreting, and presenting the data. They form the theoretical backbone of the machine learning algorithms such as linear regression or Bayesian models. These are, once you deep dive into ML, you will realize what are these algorithms, what does linear regression mean, and according to the data, which type of algorithm do you need to use. The fifth one is data mining. It is similar to the statistics, but it is more of analyzing large data sets to find patterns, correlations, trend. It will not only process the data, but it also analyze that how is the data going. I mean, finding items often purchased in a retail store, fraud detection. So all these things, they help us in mining the data. It uses similar techniques as machine learning, but focuses more on discovering patterns in data, often with less emphasis on predictive modeling. Yeah. Halin, next slide. Yeah. So now we'll cover the categories of learning. So even if we have choices, I mean we have options to use any algorithms from the list of algorithms that we have, or you can create on your own. But there has been how will the algorithm learn? So these are the categories of learning. Supervised learning first. So in this model, the algorithm is trained on a labeled data set, meaning the input data has corresponding output details. And for example, spam email detection classifies if an email is spam or not spam. Loan approval systems predict whether a loan should be approved based on the historical data. So where does that historical data come from? That historical data, we have provided that. We will transform or process the data in such a way that when we give an input, it will have a labeled output. If the utilization of some person of a credit card is greater than 95%, then he or she should be automatically rejected to approve the loan. If the utilization is less, or if the customer is paying his bills on time or before the due date, he should be considered for the loan approval, then he will go to the next stage. But if he is not paying his rent or his bills on the due date, then he is automatically going to be rejected for the loan. The next comes is unsupervised learning. Here, the model works with unlabeled data and tries to discover hidden patterns or structures. So, how does it work? Is it forms the groups or clusters on a similar data points based on features with predefined categories. The categories, we will provide those categories. So, but when we provide the data, it will find out some patterns. If they are related to each other, then it will create a group of them. For example, in a data set of customer transactions, the algorithm can group customers with similar purchasing patterns or similar purchasing behaviors. For example, a family, it will, if there are some bachelors going for a shopping, or if there are family people going for a shopping, their purchasing patterns would be different, and bachelors purchasing pattern would be different. They would be more into, they would be purchasing more processed foods, or ready to make foods, whereas if a person is living with family, or if there is any family person going for a shopping, he will be morely uh, purchasing the items which we can cook from scratch, pulses, flour, or and all those things. So what model will do is model will uh, segregate or group those people into different groups. The third is reinforcement learning. Sorry. So it is a goal-oriented approach where an agent learn to make decisions by interacting with an environment, by continuously receiving feedback in the form of rewards or penalties. So if a model is giving me an output, I will give him the feedback. Yes, it is correct. So it will train himself in such a way that it is a positive feedback. So I have to be I have to learn these things, or I will keep these things in my memory. And then it has penalties, as in if I do not like the output, or if the output is not related to what I am expecting. So in this way, the model is going to learn what works for it and what does not work for it. Yeah. So the ML workflow, obviously you cannot just give any kind of data, as I earlier explained. So the first is you need to collect the data, and the data should also be relevant. If you are working for a bank, if you are working for a credit card transactions, the main data you require is if your problem statement is whether a loan should be approved or not. So for the loan approval, you need to see if the user has any past history, what is the salary of the user, what are the credit cards that he has, and if and all the transactions that he's been doing with the credit cards. So you are not going to just collect any other consumer data. You are going to collect the data which is relevant to your problem statement. So collect relevant data, then prepare the data if there are any errors, if there are any null values, or if you want to transform something, basic transformations. If you want to handle the missing values, if there are missing values, do you want to put the average, mean, medium to those data? And if you want to remove the duplicates of that data. So second is you need to prepare the data. Third is you have to train the model, and you use the training data to build and train a machine learning model. Choose appropriate algorithms and tune hyperparameters. The fourth is evaluate the model. Test the model validation to test its accuracy and performance. Metrics like accuracy, precision, recall, or RMSE are commonly used. So once you deep dive into machine learning, you will see every model or every algorithm has its accuracy. So once if you are achieving more than 80%, 90% accuracy with the respective algorithms, you then decide which model suits your data better, and which model gives you accurate results or accurate prediction. Improve model performance, you can try and test by giving different parameters to your models, by using different algorithms, and then you can improve the overall accuracy of your model. So as we already saw the category of learnings, that supervised, unsupervised, and the reinforcement. So in supervised learning, we have examples like email spam detection, image recognition. Image recognition, we daily use it on our phones. I mean, your phone knows that if you are opening it, if you are opening the phone, or someone else is opening, it is not going to unlock your phone just because it knows, it has detected your face. So it is kind of a supervised learning. I mean, when you start your phone new, or if you just put your facial ID to unlock your phone, what does it first ask you? It first asks you to, show various angles on of your face to the phone, and then it retains that. And then when you second time, third time, and after that, when you open your phone, it is only going to open by your face, not by anyone else's. So these are the examples of classification supervised and regression. I mean weather forecasting, because it already has a lot of data with the weather forecasting कि ये parameters पे आज इतना ऐसा weather था, तो ये parameters पे कल क्या होने वाला है, परसों क्या होने वाला है. Market trend predictions. All these are examples of supervised learning. The second is unsupervised learning applications. So it is basically group the data into clusters based on what is the similarity between those people, or what is the similarity of those clusters. For example, customer segmentation, targeted marketing, recommender systems, recommendations, or big data visualization, feature extraction, and structure discovery. The third one is reinforcement learning applications. So here it focuses on decision making and improving outcomes through rewards and penalties, as it was explained. So examples are like robotic navigation for real world tasks, game AI for improving strategies, skill acquisition, and real time decision making in dynamic environments. Yeah. So there are the broader applications of ML which we daily see. So as I already explained, ML models identify and verify individuals by analyzing facial features. So unlocking devices using Face ID or identifying suspects, surveillance, social media tagging in photos automatically, or if you open Google Photos, it automatically group the photos of a particular people in a particular album, right? So how does it do that? Because it knows, because it uses ML in the background. Text prediction, if we are typing something, or it suggests the next word according to the previous word, or it corrects the spelling while we are typing. So applications such as email, messaging platform, grammar and spelling tools, Microsoft Words suggestion. So it increase the efficiency and improves communication quality. Self-driving cars, autonomous vehicles use machine learning to analyze their environment while driving decisions, and detecting obstacles, traffic signals, pedestrians, real-time decision making to avoid collision. So these are all the examples of a well-known car, that is Tesla, which is a proper AI ML car, you can say. Ex Machina, it's like example in media, a movie showcasing AI potentials and ethical dilemmas in creating human like intelligence. So it highlights the capabilities and risk associated to machine learning and AI in building autonomous systems. So you must watch this movie. Yeah, the next one is, if we know machine learning empowers accessible technology, ensuring inclusivity for all, breaking communication barriers, providing tools to enhance accessibility for diverse user needs. So first is Skype ASL. It is a real-time translator that converts American Sign Language into English during video chats. The second is Omni Bridge. It is a real-time solution to enable conversations between ASL users and English speakers using advanced machine learning driven translation. So the impact is it facilitates real-time communication, fostering inclusivity and reducing language barriers. The third is ParaSpeech. It is a speech therapy tool leveraging machine learning to provide real-time feedback and demonstrations. It is kind of a reinforcement learning. It guides user on lip shape and word enunciation, evaluates performance with visual and audio feedback. If you are, mistaking, if you are mispronouncing a word, it will provide you the feedback that this is now how it's pronounced. So these ML powered tools showcase how technology can create a more inclusive society, ensuring everyone has the right to communicate and access opportunities without any barriers. So yeah, I'd like to Herlin to carry on with the topic. Thank you.
Thanks, Manisha, for sharing those insights. So it is not just helping the organizations in their daily activities, it is also helping our special segment in the mankind to make the life easier. So that is the way we are giving back to the community. So I'll take it further and introduce you to Azure Machine Learning Service. So what Azure Machine Learning Service is actually. So it is basically a comprehensive suite of cloud services which are designed to streamline the process of building, training, and deploying machine learning models. So give me 1 second. I need to switch the screen. Share again. And okay, let's continue. Yeah. So I was talking about the AML, Azure Machine Learning Service. So what it does is it provides you a comprehensive suite of cloud services which are designed to streamline the process of building, training, and then deploying the machine learning models. Right. So um, what basically are the key features for Azure Machine Learning Service? We have specific Azure Cloud Services, a whole uh, big ecosystem of the secure cloud infrastructure which is there to support the machine learning workflows. So there is a seamless integration with other Azure services. So if you have your models trained and they produce certain data, where do you store the data? Azure has a solution for that. How do you process that data? Azure has a solution for that. How do you run analytics on that data? Azure has a specific service for that. Then it also includes the software development kits, the SDKs for Python and R, so that the data scientists, the developers who are building the models, who are managing the models, they can use their preferred programming language. So then you can use those programming languages to create the models. You can leverage things like Jupyter Notebooks, RStudio to create and maintain the models. Then for the developers which are more comfortable with the user friendly and drag and drop interface, we have AML Studio. So for people who like more of a low code, no code thing, the AML Studio provides a drag and drop interface for creating and managing the machine learning models, right? And then we also provide the within this, we also provide the interface of choice, which means that you can use either the command line tools. You can use your IDEs, your integrated development environments, or you can use the web-based portals to create and manage the models. So, and during all this journey, we do support collaboration with fellow developers, data scientists, and also version controls, so that it is easy for you to work together on the machine learning projects, right? So what benefits we get out of using Azure Machine Learning Service? So you get to create a model the way you want to do it, right? So it is like I want to use a more intuitive, user-friendly interface. You can use those drag and drop features in the AML Studio. I am somebody who likes to write code, so I can use the IDEs to create the models. So it is like accelerating the machine learning lifecycle right from the data preparation to the model deployment. Uh, since all the infrastructure that we provide is in Azure, so by default, we have compliance, enterprise grade compliance and security features included. And by allowing the collaboration the with your friends, your colleagues who are working on similar models, it enhances the productivity with and also provide automated machine learning mm, capabilities and some default algorithms to help you in the journey, right? So coming talking about the next slide. So let's move to Another area, what can go as an input to the Azure machine learning service. So when we talk about this enterprise grade machine learning service, we can feed it with any kind of structured or unstructured data to cover different ML scenarios. Since we have the AI Studio available, I can work with the Jupyter notebooks. I can use the user interface for automated machine learning. I can use the designer to create my own models. Then I can use the different IDs like the VS Code, or I can use the command line interface as well. In addition to the development capabilities, there are comprehensive operational capabilities specifically related to machine learning, which the Azure ML service provides. So, any scenario you want to reproduce in any kind of environment, you have the capabilities for that. Anything you want to automate in terms of the deployment of the models, creation of the models, Azure Machine Learning Service will support you that. And any data that you have used to train a particular model, or the way you have trained a particular model, if you want to train another model with similar data, or uh, train that model with additional data, uh, Azure Machine Learning can provide you with those capabilities. And all this is supported with a powerful compute system. So you don't have to worry about your infrastructure in terms of what do I have enough CPU, enough memory to support all these operations. All this is taken care by Azure, right? And while we are doing this, we do follow the responsible ML and AI mm, practices. So we ensure from a security standpoint, from a responsible AI standpoint, that you don't use these AI and machine learning models to do something which may not be used for a good purpose, right? So we want to work for something which is for the benefit of others, right? So that is where the responsible AI and ML piece comes into picture. So moving ahead to the next piece, talking about mm, a lot of different areas where we have seen the use of Azure machine learning services. So it is being used with real customers in marketing, in sales, in finance, operations, and also in human resources, right? So I can put some examples from the different areas so that you know that there are customers, real big organizations, and how they are leveraging machine learning, and especially Azure machine learning service. So if I talk about the travel industry, American Airlines, they have modernized their customer hub. They have moved it to Azure, thereby allowing them to handle like massive volumes of transactions. So the kind of volume we are talking about is 16 million real-time messages that they are handling, and they are handling around roughly around 17.4 million service calls per day. So that's the amount of data that Azure machine learning services enabling American Airlines to handle. They're also utilizing the capabilities of AML for their like logistics management, and also to help reduce the taxing time and providing the real time information to the maintenance people and also to the airline staff. Then there is TomTom, an organization which is the leader in maps and locations technology. So they are using the capabilities of Azure ML to enable the voice interaction with the infotainment system, with location search systems, and also with vehicle commands, right? So using the Azure OpenAI service, the Cosmos DB, and also the Kubernetes service, they have built an intelligent, fast, and highly scalable AI chatbot, which can be integrated with different automotive systems. Yeah. And there is a Japanese organization which which has built a chatbot, a AI-powered chatbot, to help users with their legal queries. So when somebody has a query around any particular law or a legal matter, this they type a question in the chatbot. The chatbot retrieves the summarized pages from the law books, and they help users with answers to those queries. So that is helping the end users on the research time they have to spend, so they can significantly reduce that research time. And organizations like Manulife, they migrated to the cloud, and they took advantage of the Azure AI services like the document intelligence, Azure machine learning, to help uh, better correlate the data in real time and also in the fraud detection. So that's those are like a few of the examples wherein we see Azure ML working behind the scenes to empower these organizations and then helping the end customers. So with that, I would want to conclude this session with 3 points. Machine learning basically is fundamentally changing how industries are operating, how humans are looking at the technology, and how it is enhancing the efficiency in the decision making processes. So it is transforming the technology landscape. There is a lot of advancement in the applications that are being built. So a diverse set of applications are being built day in, day out, which uses machine learning, and it uses data from all the different sectors, right? So if I am someone who wants to buy an insurance, the with machine learning capabilities, and the insurance company would have access to my health records. They so they will have insights into, do I have any existing medical issues, and if so, what kind of cover those insurance companies can provide to me, so they can make the decisions on that. So they have integrated things from all the different sectors to make a very well informed decision. And also with things like Azure ML platforms like Azure, there is a lot of room for future innovations and creating a lot of, I would say, helpful things for the mankind uh, to ease a lot of our pain points. So that's how AI and ML has been helping us. So with that, I I would say thank you for listening, and let's hear from you if you have any questions.
All right, so we do have one question from Gopal Amlekar. Do you have any link for the Paraspeech tool, please?
Yeah, sure, Gopal, we can share that. Any other questions while we are trying to share this link? So if no questions at the moment, I would say even in future, if you have any questions, feel free to reach out. Okay, and we'll be happy to help. Kamya, I'm not able to post the link in the chat. Maybe I can share it. Uh,
Yes, I have posted the
yeah.
link in the chat box
Okay.
so he can access from there.
Okay, sure. And also there is another tool, Voice It. That's another tool for the similar thing. So maybe you can use that. Yeah, okay. Any question that anybody else has, or any, if not question, then anything you want to discuss, or anywhere you need more information on?
All right, so I guess we do not have any other questions. I've posted both of your links in the chat box so he can access it from there. All right. So thank you, Manisha and Hardeen, for sharing your
Thank you,
expertise
Kamya.
and delivering such an insightful session on the fundamentals of machine learning. I am pretty sure all of us have gained deeper understanding of the core concepts, applications, and potential of ML. Thank you all for joining, and we look forward to seeing you in our upcoming sessions.
Thank you.
Sure. Thank you. Bye.
Bye.